Hey everyone, I need test data. There are a lot of data sets out there and many technologies come with their own test sets, like the New York Taxi dataset for Databricks or the AdventureWorks database for SQL Server. But I prefer to have just one data set for most of my data engineer end-to-end adventure. And I need to create real-life scenarios, multiple sources in various formats, complex ETL. I don't want to spend much time explaining what the original data model looks like when I turn an OLTP scenario into a Kimball model. And above all, I need an easy way to create ugly data. I want to put mistakes in my sources. I've seen enough demos with a happy flow and perfect data, but those demos are also the only place where I've ever run into perfect data. If I showed you tables named posts, users, votes, tags, badges, and comments, I'm guessing there's a big chance that a lot of you feel that the data looks familiar right away and might realize that it's based on the Stack Exchange data model. Stack Exchange has a data dump available free of charge. It comes as a whole bunch of both big and small XML files, and I've written some Python code to parse those files. Now if you're thinking, that sounds great, but I would actually already be happy to just have the SQL Server database with the Stack Overflow tables. I don't need all the other ones. Then you don't have to keep watching. Brent Ozar already did this, and he provides an easy download. The link to that is in the comments below. To those of you who would like to see how I did this, thanks for sticking around. My name is André Kamman. I'm Dutch and I live in Amsterdam. I'm a data engineer spending most of my time in Azure. And if you appreciate my videos and would like to see more, please don't forget to subscribe and maybe even give it a thumbs up. Now let's dive into the code, shall we? Getting the data is actually easy. All you have to do is go to the Stack Exchange data dump site, and the link is in the comments. The link is available as torrent. It's a torrent link, so you just download the whole thing. Then you have to unzip it. Just use your 7-zip, and you'll see a whole bunch of XML files. And I've got a sample right here. It looks like this, and you need to parse this thing to be able to work with it. The problem with XML like this is that it can be quite huge, and if you use the standard XML parsing methods, you'll end up with overloading the memory on your system because it builds a document object model or a DOM. So you have to do something that's called stream parsing. And turns out this is pretty simple to do in Python. So let's take a look at the code. If you've seen my previous video, you've also already seen a few of the things that I'm using, like the argument parser and the progress output that I put in out on the screen. And for this one, I'm using an extra library. There is something called LXML, and from that I'm importing the E3 command, which I'm going to need later. I am getting a few arguments, basically just the input folder and the output folder, like here's a bunch of Stack Overflow data or Stack Exchange data, and it needs to go there, basically. XML, CSV, that's the idea. The progress indicator value, I used that the last time as well, so you can see how far along are we. For most of them it doesn't matter, but if you're doing, for instance, the Stack Overflow database, it's quite big. So it might run for an hour. And there are a few ways to make this go faster. There's a trick. So there's one more, it's called meta, because all the Stack Overflow data comes with like a brother or a sister, if you will, site where people discuss things about the site. So it's not the actual questions, but it's questions about the questions and the process and the progress, which is called the meta. And if you don't want those, you don't have to do anything. It won't export them. It will skip them. If you do want them, you have to add the meta argument to the command line. Now, second part. This is a collection of the tables and the columns that are in those tables. This wasn't easy, actually. Stack Overflow has a metadata site. You can actually query it online, live. You can type queries and you get an answer. And I managed to actually, it's a SQL server underneath. So I queried the system tables to see what kind of tables and types there are. I also peeked a bit in Brent Ozar's database to see if it's roughly the same, if I'm doing it right. And I noticed right away that, for instance, posts is a view and not all those columns are there. This is a highly condensed database where especially P2 data that they don't want in there isn't in there. Anything that's not public is not in the database. Makes sense, right? If you're going to use this method instead of downloading Brent's database because you want to do other things, like then just create a SQL server but maybe play with data factory or data bricks to create other types of files or something, whatever you want to do with it. Send it to a messaging system. There's so many things that I want to do with this test data. You'll notice that it's roughly the same. There are a few extra columns that Brent's export doesn't make a lot of difference. They don't really matter to the demos that you might want to do. There's like content license is in there. And there's a few others. There's I think there's an account ID in the users table that's in there as well. That I don't think it matters much, but it's maybe good to keep that in mind. Also, if you want to import these things into a SQL Server, if you're going to go that way, and in my code I do have the create scripts for the SQL Server tables. If you go into the SQL Server subdirectory, you'll find all the provided tables with the create statements, and there is a bulk insert.sql command. I'll show you later that you can use the bulk insert the data that you've just transformed to CSV. So SQL Server is totally possible with this. As an extra bonus, there are 4 tables that are not included in the download, but they are useful to have. So I queried them on the live system. I just did the select star from link types, post history types, post types, and vote types, and downloaded those, and I'm putting them here as well. One last remark before we continue looking at the code. My code in GitHub is licensed through a MIT license. That means just use it for whatever you want to use it. That's totally cool. Stack Overflow is slightly different. They want you to attribute the author if you post something from a certain author of questions and answers. And they also want you to mention that you have this data from Stack Overflow. So my code is MIT licensed, do with it as you please, but if you use it to create something with the Stack Overflow data and post that, including data, or talk about the data in a video or on a blog, you need to use the right attribution. So the MIT license is just for my code, just so you know. Python people out there that are watching this, I'm a student. I am a Python student. If you see something that I'm skipping or doing something weird, or I'm about to blow up my computer if I run this again, let me know. I've already gotten some great comments from the past video where somebody said, you just actually did that, but you don't need to do that. You can just do it that way. And oh, thanks. I love it. That was some great feedback. And I got some other feedback, and I hope this video reflects that. Let me know. I've created a few functions that help me with this story. First of all, there's the fast scan dir function. This is, I got this function from Stack Overflow actually. This is quite a bit meta, but it allows you to scan through a directory really fast to see if there are subdirectories in the subdirectory, and then add them, and basically it returns a list of a tree of subfolders, and you just give them the root level and just comes back with all the subdirectories that are in there, no matter how many levels deep. So it's a recursive thing. The other function that you see here is the has valid files. When I exported the data from Stack Overflow, I sometimes had a directory that actually didn't contain any Stack Overflow data, and then my code would crash on trying to parse it. So now I'm checking, does this directory actually contain posts and users and whatnot? A simple check. Now there's a transform column. This is almost ETL. ETL, extract, transform, load. This is pretty common in data warehousing. I'm not just extracting the data from the XML and loading them into a CSV. I'm also transforming it along the way. Just like last time, I am removing the carriage return line feeds because they don't play well with CSV. For some reason, CSV let you, if you have the column delimiters, CSV will let you quote them out and it will handle that fine. But the row delimiter, now if it finds that, not every tool out there likes that. Most of them actually don't. They will break. So I'm taking them out and replace them with common characters for carriage return line feeds. And what I'm also doing is there is a column that is a Boolean, and it contains the text false or true. In my example with SQL Server, it doesn't like that. It doesn't like that text. It actually needs a 1 or a 0. So I'm changing that as well. I actually had to parse. This was an interesting one. Python understands Boolean, and it understands true and false as Boolean, but it didn't like me to look for if this is a Boolean, then turn it into a 0, and it didn't like that. I had to actually cast the column as a string and then compare the text to a false and a true. The documentation also said, yep, that's how it works. Okay, fine. This function write CSV from XML is basically the main function of the thing. If you've seen the last video, it's not much different. It opens up a file and it writes a file. In the last one I opened up a SQL Server result set. This one reads the XML and exports it to CSV, but there's a trick. What I'm doing is I'm creating an e3.iterparse or iterparse. It iterates, so iterparse, I'm guessing. I'm getting a context that uses the E3 functionality to parse through a stream of XML. So I can go through XML, and if I hit the tag row, because all my XML lines are rows, let me show you again. As you can see here, there is users, but then the data is all rows. So as soon as you see a line of row, that's what I need. That's what the iteration parser needs to feed me in the context. Now for every event, there's an end event, so I'm reading until the end of the row line. So I'm getting the whole information for the row and parsing that as XML. And I'm getting that element, the row element, so I can look at the attributes of that element. That's how that works. Now the event is underlined and it says you've not used it. Yeah, I know, and I don't need it, but the for loop does need it or it won't work. Maybe I'm doing something wrong here. Let me know if I missed anything, but I had to put it in there or it would complain, and now it complains that I'm not using it, which is fine with me. Doing a row counter again and the progress value and some logging like, hey, I'm here, I'm doing this. And as you saw me do last time, I'm filling up a set right away with a loop inside the set. I love this thing. I promise for my next video, if I'm talking about Python again, I'll look up what it actually is called. I'm sure it has a name, but I'm loving this construct. And what I'm doing is I'm calling the transform column function that helps me remove the carriage return line feeds and deal with the booleans. And I'm feeding it the attributes, so because they're the columns. And they get transformed, they get cleaned. So I'm building up a row, basically, but nicely cleaned in CSV format. And only if the column is present, if it exists. That's the cool part. It's reading from this collection and it goes through these columns. And if that column is not in the XML, because some of them are optional, not all of them are in there all the time. For instance, the users one has a profile image URL and it's just not always there. So if I try to put the profile image URL column in there, it says it breaks. It says this attribute doesn't exist in this element. And this is how you can test. You just go if column in element.attributes, then do this, and else just do nothing, just add nothing for column in columns. So this is me parsing the element. Now, so far so good. This sounds simple, right? You can just go through all the rows in the XML. It doesn't matter what the starting element is. It will just skip it because for one XML it will be users, for another it will be posts. It doesn't care. Only cares about the row elements. That's what the iterparse end event on tag row does. It gets you all the rows, reads the whole element, and feeds it into your loop, basically. Now, there's one more thing we need to do to make sure this works well, because, like I said in the beginning, if you parse large XML files and you don't do anything, you just call an XML function, just okay, here's a file, read this as XML. It will create something called a DOM, a document object model. And that might be quite large for large files, like the post history in the Stack Overflow thing is well over 100 million rows. My memory on my machine is 64 gigs and it did not like that. That did not go well. So what you need to do is make sure you use a function that streams. But we're not there yet. There's another thing that you need to do, and that's this one here. Because the streaming function builds the DOM along the way. So you're not starting out with a fully parsed DOM where it tries to parse the whole thing first. No, it just starts with nothing and then goes through it. But now every time I hit a row, it will try to add it to the DOM. So it still does that, but along the way. So it keeps growing and growing until it's far enough in the parsing of the file that you run out of memory and it crashes again. Same problem, just a bit later. So what this thing does, it just looks, are we done yet? No. Is there an element above me? Yeah. Remove it. So you're basically cleaning up the DOM by throwing out the stuff that you've already done along the way, so the memory doesn't go up, and that works nicely. That's basically it. So the rest of the code is just, there's a format message and a logging. I'm getting these subfolders here with the fast scan deer, so show me all the folders that you want me to parse. And then there's one little thing where if there are files in the root of this subdirectory, this little piece of code does that. If the root dir has the valid files as well, it adds the input folder to the subfolder list, basically, because the fast scan dir forgets the root folder for some reason. It doesn't do the root itself. And then we're setting a variable. Then we're logging if we're using the meta databases or not that I talked about before. And then basically the last little bit is just a loop that goes through and calls this function and creates the files. So if we're not doing meta, then we're skipping the meta files. So they have .meta somewhere in it, or they start with meta . So that it skips those, and you can include them if you want to. And then there's fairly simple root that does. So if the directory for the destination is not there, create it, and then when you've created it, go through the files in the Stack Exchange files collection that I made. See if the files exist, and then write them out to create the CSV file. And when you're done, because this is the right CSV from XML, which I'm feeding all the information, and then basically you're done. Now, there's one other thing that I wanted to mention. I am looking if the directory exists. So if you want to recreate it and it's already there, you can't just throw away the files and leave the directory empty, because it just won't generate anything. You need to throw away the directory as well, and it will recreate it. This has as an advantage that you can run multiple versions of this Stack Exchange to CSV Python code, and it will run parallel. It will just start creating subdirectories, and if the subdirectory is already there, because another version of this code already created it and is working on it, it will skip it. So if you point this code to all the whole directory with all the subdirectories of all the Stack Exchange databases, it will just start processing them in parallel, which speeds up things quite a bit. I can tell you that works a lot faster. I have a 12-core, so with hyperthreading 24 cores desktop here, and I managed to load them all to 100% processing all these files. That was pretty cool. That works nicely. Now, last thing to do, demo this thing, right? How does it work? Well, let's show you the data. First of all, I have the data here in my GitHub directory for the 4 tables that are not included in the download, so you can take those later and put them there as well. So I'll just take some test data. I'll go to the main output that has all my files unzipped. As you can see, there's 357 directories. This is quite a lot of data, especially the Stack Overflow database, which is also in here. I'm just going to take a small one. Let's do coffee, because I kind of like coffee. This is also a shameless plug to one of my favorite conferences, SQL Bits in the UK. Love it. So I'm just going to take coffee. Let's not take the meta one, because then it won't do anything by default. I'm just going to take their actual questions, copy them to the input directory. Check if the output directory is empty. Yes. So as you can see, input has a bunch of XML files, and after I run my code, output should have a bunch of CSV files. Simple as that. So just run the code. I need to do Python c GitHub stack exchange to CSV, and then very simple, from where to where. So that's the input to the output. Done, that's it. This one goes pretty fast because there's not a lot of data in here. If you do this on the Stack Overflow data, which is also part of this set, takes quite a bit longer. The cool part is though, like I explained before, you can run this multiple times and it will run on multiple CPUs, and because it looks for the directory first and skips it if the directory is already there, you can run as many as you want. Done that a few times, works very well. Now, we do now have a coffee.stackexchange.com, and inside I have CSV files. Just to prove that they work, let's go to my SQL Server. I do not have any data in it now. Let's prove that. Let's do reports, disk usage by top tables. It's empty, no records, so all good. If we want all the tables, there are a few that I mentioned before that are not included in the download, so I'll grab them now and add them to this list so we can import those as well. They're in my GitHub library and they're in the data subdirectory. Let's copy those to the output directory in the same directory. So now we have our data complete, and we can go into SQL Server. And in SQL Server you can run this bulk insert command that bulk inserts all these tables. This script is also included in the SQL Server subdirectory that has the create table statements as well that I mentioned before. Let's now bulk insert the files. I'm using the coffee thing in the as a demo thing. You may want to change this to the Stack Overflow data. Way more data is way nicer to work with. But for demo purposes, I'm just using coffee. It's quicker because it's not a lot of data. So it imported the data, and just to prove that that actually worked, let's refresh this. There you go. They all have data in them, and now you can query the data. For instance, here's a query that I have if you want to know what the most popular question is, but that hasn't been answered yet. You can ask this thing. Here we go. Let's see what it is. And it seems that the answer is how to avoid soy milk from curdling in coffee. I'm afraid you're going to have to tune into a different YouTube channel for that, because there is no milk ever in this coffee, only caffeine. See you in the next one.